board, and let's get started. Okay. So team, as I said, we are going to start from the very basics so that everybody stays on the same page. All right. So in any IT industry or in any IT world, the two main basic things that you must be knowing about are your apps and your servers, right? So what is a server and what is an application? First, we need to understand about that what is a server and what is an application. Okay. So if I'll give you a very basic example of a server, that what is a server? Server is similar to my laptop. Okay. I'm giving you a presentation on my laptop, right? So this laptop is a server. It has some configuration, it has a motherboard, it has some CPU, it has some RAM, it has some processors, right? So it has some configuration that is providing some platform so that I can run some of the application. So server is any machine, okay, any machine it is, whether it is my laptop, whether it is my desktop, whether it is a physical server or physical machine, a heavy machine that have heavy configuration. My laptop has 32 GB of RAM. Okay, there might be some servers that have 100 GB of RAM, 200 GB of RAM, because they have to support a huge application. Okay, so server is a backend process that provide you some functionality, okay, with which you can have your servers on which you can run your application. So that is first part, server, that is my laptop. Next is your application. So what is your application? Application is any software or any code compiled which do a specific objective. Okay, for example, you have your LMS portal. In mobile phone, you might have downloaded the application of Edureka. All right. So in Edureka application or GoToWebinar application that you have downloaded on your phone, it is an application. It is a software. It is a compiled form of some code. Okay. So that can be run on some specific platform. So considering your mobile phone is also a server, okay, on which you can run your application. So your application does not have any existence if you don't have a server. Okay. So if you want to use some kind of application, if you want to use some kind of application or software, you need to have some kind of software that is going to help it. Okay. So that's about your server and that's all about your application. So your application you can consider is your any software. So in any IT organization, okay, till now, mostly servers are managed by your ops team, or you can say your operation teams. What are your operation teams? Operation teams means your Linux administrator, your system administrator, your Windows administrator, your database administrator, or your monitoring team. So those teams are your operation teams. Those are going to manage your servers. If you want to create new servers, if you want to delete some old servers, if you want to manage your servers, you need to increase the capacity of your servers for your RAM, for your CPU, any kind of server management, mostly done by the ops team of your any organization. All right. Second is your application. Applications are mostly managed by your developers. Okay, so it is managed by the dev team. Okay, so applications are mostly managed by your dev team. So what dev team does? Developers write the code of your application. Okay, or you can see your dev team is a combination of your developers and testers, so that your application code is created. Your developers write the application code and then your testers perform the testing. After that, your applications are deployed on those servers. And to deploy your application on the servers, your ops teams provision some servers, they create some servers so that your application can be run on some servers. Okay, so this is about your servers and your application. So on the very basic level, this is what I wanted to show you first. Now we are going to understand what is your software development lifecycle. Okay, so your servers part we are not going to discuss in detail right now. So let's forget about your ops and servers. Let's talk about your application. So your application go through with from a cycle. Okay, your applications are created, your applications are developed with a life cycle. So that is called your SDLC. SDLC stands for your software development life cycle. Okay, so it doesn't happen that you right away create an application. Okay, it doesn't work like that. It go through a process. Your applications are created when you go through a particular process. You have to follow a process, then only your applications are created. It's just not like that, that you have an idea and this you just go and create your application. It doesn't work like that. It has a proper software development life cycle. Any organization, any IT organization follow this software development lifecycle to create any kind of application, any kind of software. It has to follow some software development lifecycle. Okay. So team, in IT history, okay, I'm talking about IT history. We used to follow different method for your software development lifecycle. First method was your waterfall method. Team, allow me a minute, please. Okay. So team, I guess if some of you are experienced, you might be knowing about your uh, software development lifecycle methods, your waterfall method and your agile methodology. But some of you freshers might not be knowing about that. So I'll let you know about that in detail. So your software development lifecycle follows a particular process. Okay, consider I have some idea that I want to develop an application. So for that, I have to follow some software development lifecycle about the history, when how your application used to develop 10 years ago. Okay, that is what I'm going to discuss right now. How your application used to get created with software development lifecycle 10 years ago. They used to follow some waterfall method. And what is your waterfall method? This is your waterfall method. Okay, in waterfall method, it simply resembles its name that it is a waterfall. Okay, if your water falls from the top to the bottom, you cannot go back, right? The water which has fallen from height to the bottom, it cannot go back to upward in the upward direction, right? So it follows the same way. That is why it is named as waterfall method. Consider I have a requirement. Okay, so team, I'm going to take a very basic example of your application called WhatsApp, because I guess most of you are aware of about the application. So I'm going to take the WhatsApp application example throughout the course so that we can connect better. So this is your requirement. I came up with an idea that I want an application for messaging purpose. Okay, so what I do, I am the client. Okay, I go to some IT organization and I ask them that I want to create some application that helps people connect on the messaging part. That is my requirement, and I went to an IT organization for that. So they said, okay, no problem, I'm going to create that application for you and I'm going to hand it over, and this is going to be this much charging and all, whatever. I'm not going to go in depth about the financials, but yes, I go to an IT organization and I ask that this is my requirement. I need an application for the messaging service. Okay. So if I have done that 10 years ago, what would have done? I go to that organization and they ask my requirement. I give them requirement that I want an application. Okay. So they will take my requirement into consideration, and that's all. After that, they are going to design. Once they receive the requirement, they will design it, they will implement it, they will do the testing also, that whatever the requirement was there, they will design it, they will implement it, they will test if that application is working fine or not, and they will do the maintenance also afterward once my application is live. Okay, so this is how it used to happen 10 years ago if I went to an organization for some messaging app. Okay, so everything looks good. What is the challenge here? What is the problem? So team, the problem here is that this part used to take much time. For example, 2 years, 3 years, 4 years of time it used to take. All right. So what was the problem? That if I come to an organization and say that I want a messaging app, they said, okay, we'll create that. They will take 2 years. In 2 years, there might be some competitors who will come up with some other messaging app and they will take the market. Okay, so in that time, what I need to provide some additional functionality with the basic messaging service so that I will stay ahead in market. Okay, so what happened? I gave the requirement to an organization. They said, okay, we'll deliver your application in 2 years of time. In the beginning, I said, okay, but consider after 1 year. After 1 year, there was another messaging application already in the market. So I went to the my IT organization and I said that there is already an application. So what I need with the messaging service, I need calling feature also added to my application because I want to stay ahead in market. One application is already in the market, so I need some extra so that people will consider my application to be used. So I need calling features also. But if you were in the waterfall method, you cannot make some changes. Consider in the 1 year of time, they take my requirement, they design, they implemented. Testing and maintenance was required for the remaining 1 year. All right. So if I come to them after 1 year that I want to make some changes, they will say that we cannot accommodate those changes now. They cannot accommodate. So what they will need, if I come up with a new requirement, they will have to start over. If I'll go to them that after 1 year I need some additional functionality, they'll say okay, we can do that, but we'll have to start over and we'll take again 2 years of time. Okay, so team, this is how it used to happen 10 years ago in the IT organization. If you want to launch a new application, this is how it used to happen. Because it was a waterfall method, you cannot make changes during the time in between. Okay, so what were the challenges with the waterfall method 10 years ago? Time to market was high. Okay, no client interaction. I told you that after 1 year, if you come back to the IT organization that I want to make some changes, they will clearly deny. Okay, they will clearly deny. They will say that now we cannot make your changes to the application. If you want, we can start over, but in between we cannot make any changes. So no client interaction used to happen during the complete 2 years of time, or whatever the deadline that IT organization has provided me. I cannot fulfill that. Okay, and requirements are rigid, as you can already understand that if I come up with any slight modification after 1 year, it cannot accommodate. So requirements are very rigid. We cannot make any changes during the mid time of your application development. Okay, so with this, these were the challenges with your waterfall method. I cannot see is how your application architecture used to happen, how the deployment and packaging used to take place, how your application infrastructure was there. We are going to see all about that. Whatever used to happen in your any IT organization 10 years ago, 15 years ago, we are going to discuss about everything. So how your application or software development lifecycle used to take place with waterfall method, we have discussed that. How your application was architectured at that time, we are going to see that also. At that time, your application was monolithic application architecture. So team, anybody know what are your monolithic application and your microservice application architecture? Anybody aware of monolithic application and microservice architecture of application? Anyone? Okay, Arvind, Samuel, Kalyan, I got your responses. Anyone else? Yes or no, you can give any answer. If you are not aware, you can say no. Microservice is dividing each service or function into its independent module. Yes, Shivam, you're right. Shivam, Adirika Guess, Anwar, Maina, Mohit, Avinash, Devojyoti, okay. Mono is packed. Arvind, okay, got it. Shubhashish, okay, got it. Okay, great team. So some of you have very good idea about your monolithic application and your microservice architecture. Okay, some of you don't. So I'm going to tell you that also in brief. Okay, so team, let's take an example of a different application now. Okay, Any banking application. All right. Consider I have a banking application of ICICI Bank. Okay. For example. All right. I have a ICICI Bank application. So if I'll talk about monolithic application is very well mannered with its name. Okay. It says monolithic means mono. Mono means one only. It means your complete application code, your complete application requirement, whatever you have for your application, whether it is your application code or your application database where your data is getting stored, everything is bundled in a single package. Okay, everything is bundled in your same package, whether it is your applications, savings, personal loans, gold loans, FD, RD, bonds, and you have your database also of your application, that your database which is holding all the details about your customers. All right, so everything is bundled together. Your complete application code is written in a single module. Okay, you have a single application which contains the complete module of your application also, and you have your database, so your database, your application, everything residing on the same server. Okay, so this is how your application used to run in your waterfall era, when your waterfall method was in use. That was an era, and there at that time you have monolithic application architecture. It means your complete application code, your complete application module, all the modules, whether it is your saving accounts, your personal loans, gold loans, FD, RD, bonds, your database, everything was bundled together on the same code, on the same server. So if anything happens, if your server crashes because of some reason, your complete application goes down. All right. If you want to upgrade your FD module in your application code, you have to bring down your complete application altogether. If you have to do your server maintenance, you have to upgrade your servers and apply some patch, you again have to bring your complete application down. So that is how it used to happen in your waterfall era. Okay, your complete application was bundled all together, and that method was called monolithic application architecture. Okay, also you used to have your physical servers at that time. Physical servers, for example, what is your physical servers? So team, if you have some experience in IT organization, have you ever seen your IT rooms or your server rooms in your organization? Some organizations still have your server rooms in the organization. Your modern companies or your new startups don't have any server rooms, but your old organization, your old brands still have server rooms in your company. So have you seen your server rooms? That is going to be in the agile. Next part I'm going to discuss is after data centers, uh, physical servers and then data centers. Okay. So team, physical servers, as you might already understand that in many organizations you have your server rooms. Okay, in server rooms what happens? You keep your servers. Consider that I have set up my IT company. In my IT company, what I am done, I have created a room where I'm going to manage my servers, my machines. I'm going to put my servers, my big servers in that room, and I'll connect to those servers with wired connections or wired network or wired remotely in my organization. But those servers are going to store all the data, all the applications they are going to support. So those are called physical servers. Whenever I deal with any servers that are physically present and I'm connecting with them via wired network or remotely, so those are physical servers. So IT organization used to have your physical servers in their own premises so that they can have your application deployed on those servers. Okay. So if I'll talk about my laptop, I always have to have my laptop, so that is also a physical server for me. But if you talk about big application, your Facebook, your ICICI Bank, or your WhatsApp, these application need servers. So if any organization are maintaining physical servers at their own location, so those are physical servers. Nowadays, it is not in fashion, but at waterfall era, physical servers were so much in use. Okay. After that, we have data centers. This is your application infrastructure. Okay. So deployment and packaging we discuss is physical server. That your servers, your application used to deploy on the physical servers. All right. But they again used to have data centers. Like in my organization, I have a data center. All right. So server room that I have been talking about, in server rooms, you have multiple servers. means multiple physical servers. But data center, again, that data centers contains all your physical servers. So data centers can be in your own organization also, or it can be at third location also, but you used to have your data centers there. Okay, so that interface is only to connect so that you can fetch some details. Those details are residing in some database at the backend. Okay, so you have your application, it is just provide you an interaction, and at the backend there is also a database that is storing all your data, so that whenever you try to access your application, you fetch some details, it is fetched by that database. So what is your monolithic application? Monolithic application means that your ICICI Bank application has multiple modules. Your personal loans, your car loans, your home loans, and your FDs, your RDs, your bonds. Okay, it has multiple modules in your application. So all those modules are bundled in a same package of your application code. Your developers have written the code for that application, and that application code is bundled in a single package. Okay, so if you have to update some particular module, that you have to update your loans module only, you don't want to update any other module, but your complete code is packaged in a single package. So if you want to update anything, your complete application downtime is required. Okay, so that is your monolithic application, and again it has some database also associated with it. So it means that your database and your application both are running on the same physical server. It means if your physical server maintenance is also required, that you have to increase your RAM, you have to increase your CPU processors, or anything that you need to do on your server's maintenance, you have to update your operating system version, you have to apply your patch on your operating system, you have to do any maintenance activity, you have to bring down your complete application down, and then you have to do your maintenance activity. So that is all about your monolithic application. Monolithic application, all the things are bundled together. They are not distributed. You'll able to understand about the monolithic in better way when I'll discuss about your microservices. Sharath, more briefly about data centers. Sharath, you'll understand about the data centers a little bit more when I'll discuss further topics. Okay, or simply I say that data centers where your multiple physical servers are residing. Consider that in your organization, if you have a server room, that server room is a data center for you. That's all about it. Okay, so I have selected two courses along with this DevOps, with this automation. So I have selected two courses along with this DevOps course, which is automation testing using test complete and Python scripting. Will this be covered in this training? Samuel, I guess not. Scripting is not included in this course. Okay, we are going to discuss about the automation tools, like all the tools I have shown you in the presentation. That is all we are going to cover, but not the scripting part. What is the difference between physical servers and data centers? Anwar, don't get confused. Physical server is simply a machine. Okay, consider that I have one laptop or I have 10 laptops. All right, consider I have 10 laptops. So all these laptops are my physical servers, and my laptops also heat. Okay, they have some fans inbuilt. All right, but if I'll have 10 to 15 laptops in the same rooms, I need some AC also. Okay, so that they can stay cool, they don't heat up too much. All right, so if I have 10 to 15 laptops working in the same small rooms, I need some AC also in that room. So that room you can consider as a data center, because there are multiple servers in that particular room, and in that particular room I need some additional functionality, additional things, so that all the servers, all the laptop will stay healthy. Okay, so this room will be called as a data center, where I'm maintaining all my laptops, all my servers. Okay, challenges: time to market was high, client interaction was not there, requirement was rigid. So to overcome all these challenges, we have to evolve, right? Evolution is a part of human race, right? Similarly, it is a part of your software development lifecycle also. Evolution is always required. So for that, your IT way evolved, and then we came to the current scenario that is called your agile. Okay. Nowadays, everyone is following agile methodology. Okay. So what is agile methodology? Now we are going to discuss about that also. All right. And related to that, what kind of application architecture we have, what is the deployment and packaging strategy we used to follow, what is your application infrastructure, everything we are going to discuss step by step. Okay. First, we are going to understand what is your agile methodology. Okay. So team, in waterfall, you can see that no more modification can be done on all the challenges you have just seen. In agile, we have a different way. Okay. This is your agile. So team, a quick question from for all of you. How many of you are not aware of agile methodology? Okay. How many of you are not aware of agile methodology? So question is for the people who are not aware about it. Okay, okay, all right, okay, got it. Okay, all right. So there are some bunch of people. All right. So we are going to discuss about the agile also in good depths. All right. So team, in agile, we were able to eliminate some of the challenges we used to have in your waterfall method. All right. And how we are going to see that. In waterfall method, you can see this is how you used to follow. In agile, we have a cyclic manner. All right. It means we can accommodate modifications in between. That was the biggest challenge with waterfall method, and we were able to eliminate that very successfully with agile. In agile, nothing is different, just the way of doing things got changed. All right. So in agile, we were able to have something in which we were able to accommodate the changes of the client. All right. So there are some terminologies with agile methodology. I know most of you are aware of it, but we are going to discuss about that also. All right. In agile methodology, we used to distribute our work in sprint plannings. Okay. In agile methodology, we used to distribute our work in sprints. All right. So sprint is mostly about of 2 weeks. It might vary. In some organization, they may follow 3 weeks sprint planning or 4 week sprint planning. It varies, but mostly it is 2 week sprint planning. Okay. So what is sprint planning? In sprint planning, we distribute our work across multiple teams. Okay. For example, we have some developers, we have some testers, we have some Linux admins, database admin, we have some monitoring team. So what we do, we distribute works across multiple teams so that they can work in parallel. Okay. In a waterfall method, we don't use to distribute our work in parallel, but in agile, we understood that we have to reduce the application lifetime. Okay. Earlier, we required 2 years to create an application. With Agile, we were able to reduce the time from 2 years to 1 year. How? By working in parallel for our application. Okay, so we used to plan some sprint, and for example, we set 2 week sprint. So we plan that in 2 weeks, this much work needs to be done by all the teams. All right, and after every 2 weeks or after completion of every sprint, we used to present our progress to the client, so that client will have also a better picture that how much work is done and how much work is remaining. And in that interaction, your client can also provide some modification idea that now we are able to accommodate, because definitely we are working in parallel, so we have some extra time to accommodate the changes as well. Okay, so after every sprint is just a duration of time, 2 weeks, 3 weeks, 4 weeks. Okay, once a distributed work for that particular sprint is done, we present that to our client. So we have a regular interaction with the client, so client doesn't feel isolated in the agile methodology which he used to feel in your waterfall method, because there was no client interaction for 2 years. So that was a big hurdle that we were able to eliminate in agile. All right. So in sprint, we need one person who is going to manage all the distribution of work. All right. Like developers cannot see what Linux admins are doing, what database admins are doing. They don't know. Okay. Testers cannot understand what monitoring team is doing. Okay. So we need a person. We need a central person who is going to distribute the work between all of them. Okay. And that person is called your Scrum Master. Okay, we have a Scrum Master. So this is your Scrum Master. Scrum Master is a person who is going to distribute your work for the particular sprint. Consider the sprint starts today. For next 2 weeks, your Scrum Master is going to distribute the work that in 2 weeks your developer has to complete this much work. Your tester has to complete this much work. Your Linux admin needs to complete this much work in these 2 weeks of time. So that Scrum Master is going to distribute that work, and that Scrum Master is going to have a daily call with all the teams. A daily call with all the teams, and that is called a stand-up call. Okay, that stand-up call usually lasts for 15 minutes only. Okay, a 15-minute call with all the team, so that we can know that how much work is done. And in that stand-up call, a stand-up call is a generalized call that we have every day for 15 minutes. And what is the purpose of that call? And what is the questions asked for that call? So there's three basic questions that is required to be answered by all the teams: that what we did yesterday, what we'll do today, and if we have any challenges or not with the work assigned to us. Okay, so in that call, consider that today we are going to have a stand-up call, and a tester was asked that what he did yesterday and what he's going to do today, and if there are any challenges done. So tester will say that this is what I did yesterday and this is what I'm planning to do today, but there's some challenges. I'm not able to understand a particular part of code that is creating some roadblocks for me. He can ask on the same call. In the same call, developer is also there, so developer can directly intervene, and he can tell to the tester that if you're facing this challenge in this particular module, try doing it a different way, and this is how it will be resolved. So this stand-up call is interaction with all the teams on a daily basis. So if they face any challenge, they can interact and communicate in a better way, so that they can eliminate all the roadblocks. So this is what happened in your agile methodology. Okay, so once your application is live after a year or as per the deadline provided, all right, and after that only your application is deployed. So we go in loops every now and then after every sprint with the client interaction. If there are any modification required, we do that also. But once it is done, we deploy our application by the end of the complete software development lifecycle. Okay, so team, this is how your agile methodology is working right now. Even now, your agile methodology is in place in many organizations. DevOps is the upcoming technology, and even DevOps is nothing different. DevOps is agile only with continuous deployment. Okay, DevOps is nothing. It is agile with continuous deployment. So it is important for you to understand what is agile. That is why I have explained all of you all this. Okay, so this is your agile methodology which we are currently following in any software development lifecycle. All right, so team, any question with agile right now? Any doubts you have with agile methodology? Anwar, you're asking, is the Scrum Master role always coincide with team? Scrum Master is a person who distribute work across multiple teams and interact with all the teams. So you can consider that the Scrum Master will be dealing with all the team leads of different teams, but Scrum Master is over and above the team lead, you can consider. What are the advantages of waterfall method over the agile? On your physical single server is gone, your complete application is gone, your database also is gone. You can create another application, but your data is also gone, right? That was a challenge. But here in your agile era, what we did, we distributed your application in a different tiers. Okay, we used to have some front end. Okay, this is your front end. Consider if I access your ICICI Bank application from my browser. Okay, this Chrome browser. So that is going to be a front end. Okay, then I have a middle tier. In middle tier, I have my application. ICICI Bank, saving accounts, personal loans, gold loans, FD, bonds, everything I have a middle tier. Now this application is interacting with the backend. I have a database on a different server now. Okay. Now, if some of you might be experienced, so you might be understanding this in a better way. You have some application servers and you have some database servers. You don't have a single servers nowadays, right? So you have distributed your application. You have some database servers, you have some application servers. It means that your application and your database is on a different servers and they connect remotely, right? Your application needs to fetch some details. They will try to access a different server where your database is residing. So this is your three-tier application. You can see this is a three-tier application architecture. Front end, middleware, and your backend. Your application interacts with a different server. So you have physical server, you have your application servers, you have your database servers, and this is how you have distributed your application in your agile era. All right. Now, next is your virtual servers. First, we have your physical servers. Now we'll talk about your virtual servers. Mm, Anwar, you're asking, can you give some example where application architecture are two-tier and three-tier? So there are not much examples for that. Lakshman, NTO means you have your web servers, DB servers like load balancer. Yes, Lakshman, exactly. You got it right. Okay. So team, now one question again. How many of you are not aware, okay, not aware about your virtual machines called your virtual box from Oracle or VMware? Okay, there are some applications in the market called VirtualBox and VMware. How many of you are not aware about them? VMware, VirtualBox, how many of you are not aware about these applications? Okay, okay, yeah, Sudha, that I guess you might be aware of virtual machines. Okay, Divi, it is not about your application. Okay, I'm just talking about the servers right now. And I think you understand about the servers now, that what are your servers? They are just your physical machines, like my laptop, your laptop. Okay, so team, some of you are not aware, so I'm going to cover that. What are your virtual servers? So here it is. So team, consider I have my laptop. Okay, my laptop is a server. Okay, that is very well understood. Now I want to run one application of Tomcat. Okay, I want to run a Tomcat application on my server. No problem, that I can do. So I'll install Tomcat server, Tomcat application I'll install, and I run my application there. But what is the configuration of my this machine? My configuration of this machine is 50 GB of RAM. I have 24 core of CPU. Okay, I have 500 GB of storage on my this laptop, on my this server, and I'm running my Tomcat application on it. Okay, so team, if you know that Tomcat is a very lightweight application, all right, if I'll talk about the practicality, my Tomcat application might only require 4 GB of RAM. All right, okay, and it might need only 2 core of CPU. and as per my application requirement, I might need only 10 GB of storage. Okay, for my Tomcat application, I just need this much of configuration: 4 GB of RAM, 2 core of CPU, and 10 GB of storage. That is all my requirement is. But my server is very heavy in nature. It has 50 GB of RAM, 24 core of CPU, and 500 gigs of storage. All right. So as my laptop is, I have Windows installed on it. That is okay. But is it feasible to run my Tomcat application on this server? Because it is a heavy server and my application is very lightweighted. Okay. So it is not advised to run your application in this manner. Okay, otherwise what I can have another application requirement that is of Nginx based. So I'll run my Nginx based application here, but it might conclude, okay, it might create conflict between these two applications. All right. So I cannot run two web based application on the same server. So to deal with this challenge, IT organizations came with a solution of virtual machines. What are your virtual machines? In virtual machine, I'll distribute my physical server resources across different virtual machines here. Okay, how it will happen? Virtual machines. We have multiple softwares in market right now. Okay, after this class is done, try to Google a little bit about your VirtualBox and VMware. What is the purpose of this? They provide your virtualization. What is virtualization? They will create your virtual servers. You have a physical servers. They will provide you an environment where you can create a laptop inside your laptop virtually. Okay, here you might install your different software. It means that this is my Windows machine. I have installed your VirtualBox. With the help of VirtualBox, I can have your different operating systems here. Okay, I might have a Linux operating system on this machine. I will have Ubuntu on this virtual machine. Okay, so team, it is, I hope you are able to understand, it is your virtual machine. It is not your physical machine. It is a virtual machine that doesn't exist actually physically, but you can treat them as a individual machines. So Linux machine or Ubuntu machine, or you can have your CentOS operating system on this machine. So these are virtual machine, just like you have created partition. Okay, so if you have Windows laptop, you can consider that you have C drive, D drive, E drive, just to provide isolation between your data. Similarly, you can have VirtualBox installed and you can have virtual machine created so that they don't disturb processing of this machine by this machine, and you can distribute your resourcing across these machines. Consider on this Linux machine, I'll say I'll assign only 10 GB of RAM. Okay, I'll assign 5 core of CPU. I'll only give it 20 GB of RAM storage. Okay, similarly on this machine, I can give 40 GB of RAM. I'll give 8 core of CPU. All right, I'll give 50 GB of storage to this machine. Okay, so that if I'll install any application on this machine, it will not intervene with the processing of this machine. So I can create virtual machine on my server so that I can provide isolation on the operating system level. Okay, so this is about your virtual machines. Sandeep, you're asking what is the problem we are trying to overcome. That I already discussed in the beginning, that if you have a very lightweight application and if you have a heavy server, you don't want to waste your resourcing of this physical servers. Your physical servers is capable of having 10 application, but you cannot directly install 10 application on that machine because they might create problem for one application by another application. Okay, so if you have your web-based application, they might collide with each other's processing. So you want to provide proper isolation, proper operating system level isolation. So that challenge was there on the physical server. Your physical server is heavy in nature. It can have 10 applications, but you don't want any intervention between an application. So you create virtual machines. Okay. 20 plus 40 is less than 60. Is it possible? Anwar, you talk about. Okay, all right. Yeah, I can reduce it. Consider that you have 2 weeks sprint planning and you are done with your 1 week work. Okay, you are done with your work in 1 week. So you won't get any new work for your next week because you had some work for 2 weeks, you completed in 1 week. Now you have 1 week free. Okay, so release cycles you have release after every 2 weeks, after every sprint. So that is limited now. So you don't have extra work to do in your free 1 week time. So limited release cycles are there. And the blame games. So team, I hope most of you have heard keywords like blame games, that developers say my code is working on my machine fine and your testers say your code is faulty, it is not working fine, your tests are getting failed. Okay, so have you seen the scenario? Blame games. Testers blame developers, developers blame testers. Does it happen? Have you seen that? Testers blaming developers, developers blaming testers, right? Yeah, all time, Sudha, right? Eduteka guess said no. Okay, then you might be working very well. Yes, all the time, frequently. Yeah. Okay. So team, that is the reason that in Agile also you don't have that much visibility. Definitely you have better visibility as compared to waterfall method in Agile, but not as better visibility as you have in DevOps. We have reduced the walls between the teams to great extent so that everybody has clear visibility that there is no scope of blame games now in DevOps. So in Agile, still blame games used to take place. Your one team is blaming other team that they are not working well. Other team blames other team that they are not working well. Okay, they have faulty code, your tests are not getting passed, and many things. So blame games is also a challenge with Agile. All right. So now, to deal with all these challenges, we came to the next era of DevOps. Okay, so team, now we are at the era of DevOps, where DevOps has taken the market, okay, or slowly taking up the market. So with the DevOps, now I am going to move from backward, okay. So far I have discussed first your development process, then application architecture, then deployment packaging, then application infrastructure. Now I'm going to move in the backward direction. First of all, your cloud. Okay. So again, taking the layman example that I gave you earlier, right? If you're hungry, so you might have your own kitchen. So what you'll do, you have all the resources. You'll have your kitchen, you have your stove, you'll have your gas, you have your vegetables, you have your spice. Okay. Everything you have to manage at your own, and you have to cook your meal at your own, and you have to feed yourself. Okay. So that is the basic thing. That is your own kitchen. That is your own data center. Another example for that, if you have to feed your hunger, you can go to a restaurant. All right. You can go to a restaurant. You can give your order and you can have your food. Then you can come back to your house. So what is different with cloud? In cloud, you can take the example of online delivery. Okay. So consider that you're hungry. Okay. You don't have your kitchen. You don't want to go to a restaurant. So what options you have to feed yourself? What you can do, you can have your application download, any application, Zomato or Swiggy or whatever. All right, you can use that application, you can order your food from any restaurant, and that food will be delivered to your house, and then you can feed yourself, right? So this is the third option you have. Similarly, in your application architecture, first was you can have your own data centers where you are going to put your physical servers. All right. Otherwise, you will have your servers, and those servers will be hosted at some other location. All right. But those hosted data centers, only that hosted data centers will be managed by IBM. That example we have taken, that hosted data center will be owned by IBM, but the servers that are residing in that hosted data center will be owned by you. Okay. You have to bear the cost of those servers all the time, even if you're using those servers or not, even your servers are shut down or not. You have to bear the price of that server. You have to pay for that server. Okay, so that is your hosted data centers. In hosted data centers, your data center is being managed by the provider, IBM or something, but you have your own servers. You have to pay for your own servers, even if they are in use or not. All right, but in cloud, what happened? You have multiple cloud providers right now in the market, if you are aware. Okay, leading they are some of the cloud provider. The leading ones are your AWS from Amazon. Okay, Amazon has Amazon Web Services, AWS. Next is your Google Cloud Platform, GCP. That is your Google Cloud Platform. And next is your Microsoft. You have Azure. Okay, Azure has from Microsoft. They are also providing you resourcing. So what they are all are doing, they are providing you resources on cloud on demand basis. Okay, they are providing you resource on demand basis. So how they are different with data center and hosted data centers? As till hosted, you were not taking care about the centers, you just have to take care about the servers. In cloud, you don't have to worry about your servers, you don't have to worry about your centers, you don't have to worry about anything. Your infrastructure, your servers will be provided to you on demand basis. You don't have to take care about anything. You just need a server, you ask your cloud provider, they will provide you a servers remotely. That's all. Okay. So in AWS or in GCP or in Azure, if you want a server where you want to host your application, you can simply ask for a particular configuration that I want a server of 2 GB of RAM, 3 core of CPU, 20 GB of storage. You just provide these details to the cloud provider, and they'll also provide you on which zone you want your server from. You want your server from USA, you want your server from China, you want your server from India, you want to have your server from Los Angeles. They provide you zones also, so you can connect to those servers remotely. So consider that I have asked for a server that is in Los Angeles, so that server will be residing there. So if I'll talk about AWS, your AWS is going to be taking care about your data centers. They will be taking care about the servers. They will be owning that servers. You have to pay for the time you are using those servers. You can terminate your virtual connection, remote connection, once your connection is done. Or even if you have kept your machine offline, your machine is in shutdown state, you don't have to pay for that time. You just need to pay when your server are live and you are using those servers. Even if you shut down those servers, you don't have to pay for it. Okay, so your application architecture has been evolved in this manner that you have your servers on demand remotely. You don't have to take care about your servers physically on your own premises. So that is about your cloud. Next, your deployment and packaging. First, we used to have physical servers. Then we came to virtual servers. All right. Now we have the same virtual servers on cloud. Okay. Consider I have a virtual machine from GCP or from AWS. All right. On those servers, now I am going to create containers. What are containers? Okay. Containers also solve the same purpose as your virtual machine. Okay. Considering the same example that I have a physical servers, I'll create multiple virtual machines. Containers also provide you the same functionality. You have one virtual server. In that virtual server or physical server, whatever you have, you can create multiple containers for your application. Okay. They solve the same purpose your virtual machine was solving on your physical servers. Same purpose they are also serving. Then what is the difference? The same purpose the virtual machine were also solving, same purpose your containers are also serving. So what is the difference? Why we move from virtual machine to containers when they both are solving the same purpose? So the thing is, there were some challenges with virtual machine we haven't discussed about. Okay. Consider I have created 2 GB of RAM on this one of Linux flavor. All right. So consider my application load is increasing. I need to increase this 20 GB to 30 GB. All right, I need to increase it to 30 GB. So to increase the capacity of RAM on this machine, I have to shut down this machine first, then assign it 30 GB RAM, and then I have to take a reboot on this machine. So it will incur some downtime of my application, right? But in containers, your containers run itself as an application. So dynamically resource allocation is there. By default, this container doesn't require 20 GB of hardcore resourcing. It will take only bare minimum 1 GB or maybe 200 MB or 300 MB as much as required to keep this container alive, to keep this application running. After that, on this container, if you install Tomcat or any other server, sorry, any other application, and that application is requiring 5 GB, so it will take 5 GB from your servers dynamically. If this application requires 10 GB now, it will take 10 GB from your physical servers, from your main servers dynamically. So dynamic resource allocation is there, which was absent in your virtual machine. So similar challenges were there in your virtual machine. To overcome that, we move to containers. Okay. To discuss on containers in depth, we have dedicated section for that. We have Docker containers and we have Kubernetes for your container orchestration. But as of now, on the first day, for the basic level, what is your containers? What is the purpose of container? I am going to explain you that much only in this part. But we are going to discuss all this in depth later on. Okay, so that's all about your containers. Next is your microservices. Okay, now your microservice architecture is different from your entire and monolithic, but how? In monolithic, I told you there are two fronts. Okay, in monolithic you have two fronts. Two fronts by I mean first front was your application code, your complete application code. If I was talking about your ICICI Bank application, you have your ICICI Bank application code, right? In that code, you have modules for your loans, you have modules for your RD, you have your modules for FD, you have your modules for bonds, okay? You have your module for home loans. So you have multiple modules and all the modules code of your application is bundled in a single package. So that is your one front of monolithic application architecture. Second front was having your application, your database and everything on the single server. That was second front. Okay. So your second front challenge was already removed from NTR. It means your application tier was distributed. You used to have your front end differently, your back end differently, you have database on a different servers, you have the application on a different server, you have web servers differently. Okay, so monolithic application was distributed on your server level, but still uh, your complete application code is residing on the same server in a single module, in a single package. Your ICICI Bank, your saving account, your personal loans, gold loan, FD, RD, everything is still residing on the same module, right? So still, if I want to do some update on personal loans module, I want to upgrade something, I want to upgrade some functionality, still I need to bring this complete application down, right? I still need to bring this complete application down. But if I talk about microservice architecture, what is your microservice architecture? Consider that your saving account is one service, your personal loan is another service, your gold loan is another service, FD is different service, RD, bonds, all are different services. As of now, those all services are bundled in a single package. Okay, now to deal with this, what I'll do, I'll distribute this into multiple services, multiple microservices. Consider on one container, I'll be running my saving accounts functionality. Okay. In another container, I'll be running my loans. Okay. On another container, I'll be running my FD, FD or RD. All right. On another module, I'll be running my bonds, right? So I have distributed my application also into different modules, or you can say I have distributed all the services in a microservice. Savings is a different service, loans is a different service running on different containers, FD and RD are different modules or different service running on different containers, bonds are running on a different container. So what I achieved with this, what did I achieve? So if I want to upgrade any loan specific module of my application, I am upgrading any loan specific module of my application. So what I need to do, I just need to upgrade this part. I'll just modify the code of this loans module, and I will bring this container down, update my code, and bring this container back online. What did I achieve with this? My complete application is still live. My complete application is still up and running. Okay. My complete application downtime is not required right now. Just my this module will be down for some time, and my another containers will be running. So I will be able to access my bonds. I will be able to access my FDARD. I will be able to access my saving account details, but I won't be able to access my loans for some period of time. Okay. So what I was able to achieve, I was able to reduce my complete application downtime to a great extent with microservice architecture, which was not present in any other application architecture in my previous generations. Okay. So this is all about your cloud containers and microservices. If you have any question related to all of this, let me know. I'll explain you again. Okay. What is the difference between private cloud and hosted servers? Elude cloud is on demand basis. Okay. On hosted servers, on hosted data centers, you have to purchase the servers and you have to manage your servers in some third location. All right. So those server rooms will be maintained by the hoster, but you have to pay for the servers. You have to purchase those servers. So even if you're not using those servers for some period of time, you have purchased them, you have paid the price for that. But on cloud you don't pay for the servers, because on cloud you never purchase a server. You only pay for the duration you are serving for those servers. Okay. So you can say that you are renting those servers, because nowadays it is never suggested to purchase the servers, because you don't need those servers to be purchased. You can rent those servers. So on cloud you can rent servers, on hosted you have to purchase the servers. That is the difference. Manish, you are saying repeat the container part. We covered in agile follows the same. Now few other things I'm going to explain you from the slides. Okay, last 30 minutes, let's see what we have in slides now. Okay, so team, these are the challenge working. All right. So team, as of now, you have seen waterfall diagram. Okay, it was like a waterfall exactly. Okay, in agile we had a single loop. Okay, we had a single loop. But in DevOps, you can see we have a infinity loop cycle. All right. So this is how we differentiate between all these methodology. In here, we plan, we code, we build, we do testing, we release, we deploy, we operate, we monitor, and again we plan. Okay, so it is an infinity loop cycle. Okay, so team, this is the diagram that is going to help you understand about the difference between agile and your DevOps. Okay, so in waterfall method, how we used to design, then we used to code for